Hello and welcome to the 10th video in this series, making simple Flappy Robin for the iPhone and iPad using Cocos2d. So this video then, hopefully it won't take too long, but we're going to flesh out these empty functions which we put into the last video along with the tube class. Before we do that, we need to add a few more constants which I forgot. The first one I want to add is a k, z-index, tube obviously, and we'll give this 35, and then down the bottom here I want to add a few more constants in as well. I'm just going to make a bit of space to scroll everything up. So we'll put in, we won't use it, but for now k tube score, lest I forget later on, so a point per tube pass, so for a pair we'll score 2 points. And then we want to define some tube types, so we'll say k tube type and upper, which can have a 0, and then we're going to have lower pair, so lower and pair, and also none. So 3, a 2, and a 1. Good. Okay, so that's those in. And the last one I want to do is something called define k tube max up pixels. And this will be 180 multiplied by the y scale factor. And I'll explain what this is. Before I do that though, you'll notice here maybe from the last video I've halved all of the values here, because I did a bit of prep obviously for this video just to check I could somewhere get to the working game with the tubes, and the gaps and everything were completely ridiculous in the positioning, and it dawned on me that I'd based these on pixels 640 high, but of course it's 320 points in the application, not 640, and then we multiply obviously for the iPad. So once I put these values in, everything looked a lot more sensible. So you may be wondering what this k-tube max up pixels is. Well, I'm just going to bring across sort of a screenshot image that I use for the videos, and if you imagine this was the game where the Robin goes under this tube in the middle, well, he's got to get over this tube then here. And obviously once the Robin's cleared this, because of the gap between these, there's a finite maximum that the Robin can actually go up in y pixels before he'll hit the tube, where it's effectively it has to go up too far for the gap in question, and therefore it's impossible to make some of the gaps. Well, you don't want that in the gameplay. So what I do is I use this constant here to basically say that for the minimum time or gap, which is 2.3 seconds between the tubes, that the Robin can go up, I found a maximum of around 180 you can achieve and still get over. Anything less than that, and it's very, very difficult. So when we come to generating the tubes, we'll always be checking that if the Robin has had to, with the previously generated tube, go under a tube, either be it for a pair or for the upper type, then we have to make sure that we maximize the Y position if it's a lower type, so that it's actually possible for the Robin to get over the tube. So that's what that's for here. And obviously all of these constants here are all done like this in constants, so that it's actually very easy for us to change the gameplay just by adjusting the values inside this file. In fact, if you think about it, everything, so the speeds of the clouds, the trees, the scale, the sizes of the clouds, the timings of the tubes coming in, and the gaps and everything, we don't really need to touch any code at all. We just need to change these numbers inside here, and we can see instantly the effect on the gameplay. So it's a good example of why constants are much better than hard coding values into the code. Okay, good. So now those constants are in, we can get into the nitty-gritty of it, which is actually getting everything up and running. So what we need to add in is a couple of variables at the top of, and by the way, I'm in the intro scene.m. The first one's a bit of a hack, well they both are really, but we've got one called middle y here, and another one's going to be called last get under y. And the middle y is actually going to simply store in points the middle of the screen in the y direction. So I'm just going to say middle height y equals screen size, this is inside the init, dot height divided by 2. And then the last get under y we'll set that to 0 just to initialize it inside at the bottom of the init function. But what that will record is for the last tube that was spawned, if it's a type where you have to go underneath the a tube, so a pair or it's an upper type, so you have to go underneath it, then it will store the Y position. So if I just bring the image back across, say the robin had to get between this pair, then last upper Y would be the base of this tube here. If it had to get over one, then it would just be set to the top of the screen, and likewise if it had to get under this one in the middle here, last under Y would be here. And that's just to make sure that's what we use to make sure that we don't ask the robin to then go up to over this sort of 180 max that we set that it has to get over. Falling down, there isn't such a problem because of the way the gravity acceleration works, it ends up falling down very quickly and can essentially within that 2.3 seconds cover the entire screen. Okay, so that's those added in. Middle Y and last get under Y are initialized inside init, and now we can start filling in bit by bit this code. So the easiest part of the code is the spawn time. So last spawn time equals 0. This is basically time since we last spawned a tube. Well, we'll set that back to 0, reset that to 0, and then we say the next spawn time equals, and now what we want to do is we want our min spawn time from our constant, so the 2.3, plus a random 0 to 0.8 of a second. Now we'll use rand for this, but rand of course is in integers, which is why I specified the constant, here as an 8 and not a 0.8. So what we'll actually do is we'll say rand moduloed by the k min k tube spawn time variance, so that gives us something between 0 and 8. Divide that by 10. But first of all, obviously, before we divide by 10, because we can't divide an integer by 10, else we'll just end up with a 0 or 1 or whatever, we'll cast this to a float. So we've got, the darn IntelliSense. So we have we cast this result, first of all, this random number from 0 to 7 as a float, and then we divide that float by 10, and then we can add on our spawn min time like so. So actually we'll end up with 2.3 to 3.0 because obviously this will be 0 to 7. Okay, so that's the next spawn time and the last spawn time, and that's simply incremented in update. You'll see how this works. So set spawn time is done, and that's the simplest of all the functions. The next one is to spawn a new tubes, and the way we're going to do this is we're going to base it on chance. We have 3 types of tube. That's if I just bring the image across again, that's the pair type here. This type here is called a lower, where it comes from the bottom of the screen. This type here in the middle is called an upper, and we want a couple of things. One is we don't want to repeat the type, and 2, we want an equal chance of type. So we'll just say rand moduloed by 3 plus 1 will get us a number from 1 to 3. And now what we want to say is that if it's a 1, spawn an upper, if it's a 2, spawn a lower, and if it's a 3, spawn a pair. However, we need to make sure we're not repeating type. So we'll do something horrible in the code here and make an infinite while loop. And now what I'm going to say is if last tube type is equal to k tube type upper, and our chance is equal to 1, which says we want an upper, then we're going to have to regenerate our chance because we've generated a 1, but last time we already spawned an upper. So we'll just regenerate, and what will happen is the while loop will execute again, and at some point obviously we'll end up with something other than a 1. So what we can say then here is then else if, and I'll just copy this line in here, be lazy, and then we want k tube type lower, and our chance equals 2. Then exactly the same thing has occurred. Let's generate our chance again, and then we want else if the last tube type equals k tube type pair, and our chance equals 3, then we'll generate our chance again. And at some point, obviously very quickly in terms of computation, it's a blink of an eye, we'll end up with something different so that we'll spawn something else. Otherwise, if there wasn't a repeat, then we can simply break out of the while loop. We're not going to repeat what we the type of tube. So now what we can do is we can say then if I could use a switch, I suppose, but say if chance equals 1, then we say self and spawn upper or lower, and then a yes because it's the upper type with the 1, else, and then I'll just drag and copy this to try and get things moving along. Else if our chance equals 2, then we'll put a no because it's not upper. Otherwise we've only got one more possibility obviously, which is we'll say self and spawn tube pair, like so. So this function then is what will be done when it's time to spawn. So when our last spawned, our time since the last spawn has exceeded next spawn time, this will be called, and this one then decides what type we want to spawn, guaranteeing it's a different to the previous type. So now we come to spawning an upper or a lower tube, and this is probably the most complicated function in here, and the complexity is simply making sure that the gaps to the top or the bottom of the screen, depending on the type, are big enough, and also that again it's possible for the robin to get over or under the tube. So the first thing we do is say last tube type. Now we'll set that, we'll say is upper equals true. If so, then it was k tube type upper, otherwise it is k tube type lower. I like using the conditional if like this because it keeps things a lot shorter, and what we need is we need a range of the y. So we'll say that our y max, so the highest y, depending again on is upper. So if it's an upper type, so coming from the top of the screen, then the y max, the top y, will be our middle y, the middle of the screen. And the way it's done, just to read, the middle one here is an upper type. The y of the upper is at the base of the tube here, because we'll set the anchor point there. So basically we're saying the tube has to come at least down to the middle of the screen. For a lower type, the y is set to the top of the tube here, just for reference. I mean, I'm sure if you look through this stuff, write it out on paper, it's fairly easy to get, but when you look at it like this, it's not. Otherwise, we'll have k single gap top, because it's not an upper, so we just want to make sure it goes up to maximum height of k single gap top. And int y min is basically the reverse of that, so we say is upper equals true. So what's the lowest y we can have? We have k single gap bottom if it's an upper type, otherwise again we'll have middle y. So that gives us our y max and our y min depending on the type of tube of where we want to say. So we've got the range basically. But what we do need to check, like I said, is if we're in the case of a lower, the robin can get over it. So we'll say that if is upper equals false, so it's not an upper type, then we need to make sure that our y max minus the last get under y is less than the max up pixels, so it's possible. So if y max minus and last get under y is greater than k tube, where is it? Max up pixels. So if it's going to be going over a lower, but the range is too big, then we'll set it to k tube max up pixels. So we'll say that y max is equal to k tube max up pixels, which guarantees the robin can achieve it. So now we can get our range of y, and we'll just get this as an integer. So y range equals then, and we want absolute of y max minus y min, because we want the range as positive. And I've not spelt that correctly. I'm trying to go too quickly here because I'm conscious of the time. Okay, so we have our range of y now, and now we can use this range with our y max to get ourselves where we want the y to be. So just to reiterate the point, bringing this across here, say we've got this lower tube here, this would now have a y range of say anywhere from the middle of the screen up to about here, and now we're going to generate a random position in that range, which is then the position of the tube. So what we'll say then is that the y position, and we'll just do it as an integer, equals the y max minus then a rand moduloed by the y range, which gives us then a random Y position within a range that we know the robin can achieve. And then we just say if is upper equals true. So if it's an upper type, then we want to say that the last get under Y equals the Y position. Otherwise, it was a lower type, so we'll just say that the last get under Y is equal to the middle Y, the middle of the screen. Just to make sure that next time round when we've got a lower, we can then do all this calculation to make sure it's achievable for the robin. And last but not least, finally, at the end of here, we can call self and spawn a new tube. And we want to say whether it is an upper or not. And now we have the Y position that we want to spawn our tube. And that's all we need to do there. And that's the most complicated function. And the problem is, and you can imagine when I first wrote this, and there was a bit of head scratching going on to get all this looking right, but it isn't so bad once you understand it. So the simpler part is spawning the tube pair, because the gap is already guaranteed by the constants we specified. It's got a minimum gap, a maximum gap, and because they're positioned more or less in the middle of the screen, the pair, all the time, there's never any worry about the robin being able to get from either an upper or lower through the gap then. So again, we specify our last tube type, which equals k tube type pair, because that's what it'll be now. And now we want our gap, so we'll have our gap, and that will equal to k double gap min, and then plus, and this is where we generate our random gap. So we want a random moduloed by, and then we'll do an int cast of k double gap max and minus k double gap min. So this basically, between our max and min, gets us a random gap. Now we get our Y range, so we say our Y range then is equal to our k double gap top, so the highest up the gap can be from the tube pair, minus our gap, and minus k double gap bottom. Again, I'd recommend you just go and look at the constants here if you want to just get your head around this. Int top Y, so the top part is going to then be k double gap top, and minus, and again we'll make this random modulo by our Y range, so that gets us our random position of the top of the pair. So we've basically got our random gap, and now we need to position the top of the pair. So the two things we're doing here, we have a pair here, we're making this gap here random, and then we're making the position of the top here also random within a certain range defined by our double gap constants, like so. So we've now got then the bottom Y, obviously, which would be our top Y, then minus our gap. It's fairly self-explanatory. And now we can use these to specify our variables. So last get under Y then obviously will be now equal to our top Y. And then we can say self and spawn new tube. We'll spawn an upper tube and it's at Y position top Y. And then we spawn a lower tube because remember it's a pair, so we spawn new tube. It's a lower, so it's a no, and this time obviously it's at the position of bottom Y. So there, that's completed as well. So that's not really as confusing to look at probably as this one, but I imagine by now you're getting the idea. All we're doing is making sure everything is within a certain contained range specified by our constants. So last couple of functions now then. Spawning a new tube, and this is fairly simple. We basically say we get our next tube, so we'll call it a next tube like so, and also that's equal to self and get next tube, which is the function we haven't written yet below. And now we have this tube, we can say if is upper, oops, sorry, not sorry, if yes, if is sorry, I had a a brain freeze there. If it's an upper type that we're spawning, then we need to make sure we set the anchor points, remember, because if it's an upper type coming down, then we want the anchor point for the Y at 0. However, if it's a lower type, then we want the anchor point for the Y at the 1, so it's on the top of the tube like this. And we also need to say we need to flip, if it's a lower type, then we actually need to flip the tube, because the tube graphic, I'll just bring it up here, is this way, so we need to flip it the other way up if it's coming from the bottom of the screen if it's the lower type. So if it's an upper, then we say next tube, and then there's a set anchor point, and we want to set the point to 0.5 for the X, and because it's an upper, then it gets set to 0 like so. And I'll just put an else here before I go into the flip and just drop this in here. So if it's the lower, then we want the Y as a 1. And now we want to do a next tube and set flip Y to no in this case. You might think then, well, it's by default it's no, so why do we do this? Well, it might already have been a lower tube and be flipped, so we flip it back just in case, and then set flip Y to a yes. And last but not least, then we take the next tube and then we need to set its position, and its position then is set to CCP, and then it's next tube dot position dot X, and then the Y position. And now we can finally on this tube call start, which will set it then scrolling across the screen. So at last we've reached the last function here, which is the get next tube. And the way we do this then is, first of all, we'll look for one inside our tube objects array. So we'll say for C tube and pointer to tube in and its tube objects. So we'll look for all of the tubes in the tube objects, and we'll say that if our tube.state is equal to k tube state inactive, so it's off the screen, then we can return this tube to be used. Otherwise we need to create a new tube, so we'll say cg size, you've seen this before, screen size equals, and then we want cc director, shared director, and its view size, like so, because we'll need that for initialization. So we can say ctube pointer to new tube equals, and we have ctube sprite with image named, and in this case it's tube.png. The tube will be available obviously for download. And now we can say new tube, and we want to initialize with speed, and the speed is k cloud speed tree, moves the same speed as the trees to the tubes, and the width then is our screen size dot width, so it knows the screen width. Then let's add it to our screen, so self, add child, and then we've got new tube, and we want the z of the k z index tube, like so, stuff you've seen many times before. Of course, we mustn't forget to add it to our tube objects, so tube objects and add object new tube. And last but not least, we can return our new tube. So that's quite a lot of code and quite involved in all of this, but that's all we need to get the tubes up and running. And now what we need to do is actually the worst part for me, which is actually to put the logic in, because I always forget something here. So first of all, let's have a look at the start game part of this. When we start the game, we'll set the last tube type equal to k tube type none, to make sure it's set to something and not some arbitrary number when the game started up. We'll reset last get under y to middle y, to the middle of the screen. And we want to spawn something straight away, so we'll say that the next spawn time should be in 0.2 seconds. So at least we get something spawned instantly and don't have to wait a couple of seconds. And that means all we need to do now is go into the update here, and assuming that the game is in progress, the game's been started, we can say that the time since the last spawn we add on to our delta here, and I'm just checking, did I make that next spawn time here? Yes, I did, 0.2. Good. Okay, good. And what we can say then is that if our last spawn time is greater than our next spawn time, then the first thing we'll do is call set spawn time, because we want to reset now to spawn it, and then we can call the spawn new tubes, which sets off this chain of functions that we've just filled in down the bottom here to spawn either a pair or an upper or lower. Now, where was it that I just typed that, because I went too quickly there and you might not have seen it. So here. And that, fingers crossed, should all we need to do. I'm just going to build now to be able to run the application and see tubes flying across the screen. So I've got at the moment, I think I'm going to go for the iPhone 3.5-inch Retina with iOS 7.0 and hit run. Device starts up, and let's just start and see what happens. And you can see now that the tubes, well, there's one tube, oh good, there's a pair as well, are appearing on the screen, and it's starting now to look more or less like the finished product should. I've noticed the gap already really is a bit tight here. I'll probably have to adjust the speeds or the minimum time between them. We haven't got any collision in, obviously, at the moment with the Robin going, so it can hit the tubes. We can deal with that obviously in coming videos. The gaps are a little bit tight, probably have to adjust the times, but overall it looks pretty much like it's working okay. Let's go and do this on the iPad just to take a quick look at how it looks on the iPad. So this should look relatively similar to how it did just now on the iPhone Retina, and yes, obviously the iPad's different aspects, so it's narrower, but my first impression is that the speeds and the gaps and things and proportions are all pretty much okay, and I'll assume that the iPad Retina is also then okay. I suppose I could just have one last check on the iPhone non-Retina, even though I imagine in a few months they won't exist anymore. Let's have a look what this does. Tiny screen, but yes, everything also looks, it's quite a big gap for the first tube there actually. Okay, there's a good smaller gap coming afterwards. Good, so everything looks proportionally the same and like it's working okay. So I'll stop that there then, and that's it then for this video. So the last couple of videos really were quite involved, took a lot of code and quite long. I apologise about that. I'll try and keep the length of the videos from now on down a bit, and really the hardest part of all the programming is done now. The collision for the Robin and the scoring and stuff is all relatively easy and pretty achieved in a pretty short time. So thanks very much for watching. Comments, questions, criticisms welcome as always on YouTube.